This is a video for the review for our first word problems quiz in Algebra 1 with Lab. All right, first things first. Whenever you do a word problem, we've talked about this in class. I guess I'm saying this more for the parents, but what we do is we split up our paper into 3 columns. Okay, like so. I usually make the second column a little wider than the first and the third. And here's the idea. The first column is for the setup of the word problem. This is kind of where we translate the words into algebra. The next column is for us to write and solve an equation. Then the third part is to look back and answer the question. And I instruct the students to set up the word problems this way because it gives them a systematic way to understand how to do these for every single word problem. Even though the word problems can be a little different, if they think of the problems in this fashion, they will have a higher chance of getting them right. So, number 1 says, the larger of 2 numbers is 9 more than twice the smaller. That sentence needs to be translated into algebra. The key is you look at the end of the sentence. So, for example, the larger of 2 numbers is 9 more than twice the smaller. The thing that comes at the end, we're going to call that x, because that's what everything is in terms of in this sentence. The larger of 2 numbers is written in terms of the smaller. So at the end of the sentence, you will find your x. And in our setup column, we're going to write x equals the smaller number. The subject of the sentence is the larger number. The larger of 2 numbers is 9 more than twice the smaller number. Well, I can say that thinking like I could think of this as 9 more than twice x. 9 more than twice x would be 2x, that's twice x, plus 9. That's the 9 more than part. And that's the larger number. Now we've translated that sentence. And we keep reading. The sum of the 2 numbers and 18 is 162. This next sentence needs to get translated, but this next sentence is going to get translated in terms of an equation. This sentence helps us get the equation. So firstly, we have the sum of 2 numbers and 18 is 162. Is the equal sign. So I'm going to write equals 162. The sum of the 2 numbers, meaning the smaller and the larger. So I'm going to take the sum of the smaller. Here's my smaller, and the larger, and 18. People miss this. And I'm adding 18 equals 162. And now here I have now set up an equation. The word sum means addition. I have added the 3 items they've told me to add. Now I'm going to solve this equation. And when I solve it, I'll get x by itself. So x plus 2x is 3x. 9 plus 18 is 27. That equals 162. 162, we'll subtract 27 from both sides. And so 3x equals 135. And divided by 3, x is 45. The third column is to look back and answer the question. I know x is 45. The question asks me to find, and find is another good word to underline, the smaller number. So I look back and I say, oh, look, here's my smaller number in my setup column. It was just x. So the smaller number was just x, and x is 45. So the smaller number is 45. That's our final answer. Now, just as a side note, if they asked us for the larger number, I would take the 45 and substitute it in for x, and I would get 2 times 45 plus 9, which happens to be 99. So if they asked me for the larger number, it would be 99. But the smaller number is what they wanted, so the answer is 45. All right, number 2. This one's a little harder to set up. Daniel, Gianna, and Allie are selling candles for the freshman class. There's really no math information there. And by the way, I'm setting up my columns. The next part says Daniel sold triple as many candles as Gianna. And then it goes on, it says, and Allie sold 4 less than twice as many candles as Daniel, and a lot of other stuff. I want to stop reading at Gianna because there's a piece of information there. I've hit a comma. Okay, that's one of the tools we look to see where we can stop reading. Daniel sold triple as many candles as Gianna. Gianna comes at the end of the sentence, so X will be assigned to the number of candles. That's what we're talking about. Gianna sold. Okay. Now, Daniel is the subject of the sentence. Daniel sold triple as many candles as Gianna. Triple X. So triple X is just 3 times X. So this is the number of candles Daniel sold. Then it says, if we keep reading, and Allie sold 4 less than twice as many candles as Daniel. Now, the confusion here is some people think, well, then Daniel should become X. But we already assigned X to Gianna's number of candles. And we already assigned 3X to Daniel's number of candles. So right now, I want to think of Daniel as 3X. Allie sold 4 less than twice 3X. 4 less than needs to get translated backwards. So I'm going to subtract 4 at the end. Twice 3X. Twice 3X is 2 times 3X. I want to write that up here. This is 2 times 3X. Twice the 3X. Twice Daniel's number of candles. And 2 times 3X is 6X. So this is going to be 6X minus 4, and that will represent the number of candles that Allie sold. And now I have my setup done. It says altogether they sold 46 candles. So altogether, I can take the 3 expressions that I have for the number of candles each person sold and add them together to get 46. So I'll write X plus 3X plus 6X minus 4 equals 46. There's my equation. And now we'll solve the equation. X plus 3X plus 6X is 10X. Remember, there's a 1 in front of the X. Minus 4 equals 46. Add 4 to both sides. 10X equals 50 divided by 10. And X equals 5. The third column is reserved for answering the question. The question says, how many candles did Daniel sell? So I go back to my setup and find Daniel's number of candles. Daniel's number of candles was 3X. So 3X was the number of candles Daniel sold. And so I could do 3 now. I could substitute in 5 for the X, and I get 15. So Daniel sold 15 candles. That's the final answer to the question. All right. Number 3. Mrs. Zoll is decorating her classroom for Halloween. She wants to put a Halloween border around the edge of the rectangular floor in her room. Well, in my setup column, now we're talking a little bit of geometry here. We're talking about a rectangle. So I want to draw a rectangle. This is Mrs. Zoll's floor. The width of Mrs. Zoll's classroom is 5 less than twice the length of the room, and Mrs. Zoll figured out that she will need 80 feet of border to cover the edge of the floor. What is the area of Mrs. Zoll's classroom floor? Now, I read that whole thing out loud to give us some practice in reading the first through, and then I'm going to go back and read this again and stop where I need to stop. So it says the width of Mrs. Zoll's classroom is 5 less than twice the length of the room, and some other stuff. I stop reading right here, okay? The width of Mrs. Zoll's classroom is 5 less than twice the length of the room. What object comes at the end of that sentence? Well, it's the length of the room. The length comes at the end of that part of the sentence. So that's going to be X. So X is going to be the length of the room. I'm just going to write length because we know it's a room. Then, what's the subject about? Well, the subject is the width of the sentence. The subject of the sentence is the width. Sorry. The width of Mrs. Zoll's classroom is 5 less than twice the length. or 5 less than twice x. Less than gets translated backwards. So 5 less than is minus 5. I'm going to go backwards here. So I'm going to write my minus 5, and then in front of it, I'm going to write something. 5 less than twice the length, 2 times x. So this translates to 2x minus 5, and that's the width. And now with a geometry problem, I'm going to go back up to the picture and label my sides. I usually use the length as the left and the right, and the width as the top and the bottom. Now, Mrs. Zoll figured out that she will need 80 feet of border to cover the edge of the floor. Mrs. Zoll is going to border up her entire floor. Okay? This is when I say you have to be a good security guard. This concept is called perimeter. If you walk the perimeter, you have to walk around all of the edges. Okay? You have to walk around all of the edges. Or if you had a dog and you only fenced off 2 parts out of the 4, the dog could get loose. Okay? So I need to add up all 4 sides to get 80. So I have my x, check it off, plus my 2x minus 5, check it off, plus my x, check it off, plus the 2x minus 5, check it off, and that equals 80. I need to add all 4 sides of the rectangle. Now we can combine our like terms. I have my x, my 2x, my x, my 2x. I'll put 1s in front of my x's, and altogether we have 6x. I have negative 5 plus negative 5, which is negative 10, not positive 10. Do that on your calculator. Equals 80. Add 10 to both sides. 6x equals 90. Divide by 6, and x is 15. Again, we solved, but we didn't answer the question. That's what the third column is reserved for. The question is, what is the area of Mrs. Zoll's classroom floor? And in other words, if I want to fill up the classroom floor, how many squares would I need? So I want to fill up this floor right here. How many squares would I need to fill it up? And the formula for area is length times width. So I need to get both the length and the width. Well, the length is easy. The length is just x. If I look back to my setup column, length was x. So the length was just x, which is 15. The width, however, is 2 times x minus 5. And x was 15. 2 times 15 is 30. 30 minus 5 is 25. So here I have my 25 for the width, 15 for the length. The area is 15, the length, times 25, the width. And this turns out to be 375. Now here's the other thing that I said. If the word problem has units, you need to use correct units. So now let's think about this for a minute. 15 was measured in feet. 25 was measured in feet. I'm doing feet times feet, which is feet squared, or square feet. Now I told you, look at the floor of our classroom, or if you have a tile-based floor at home, look at the tile. It's made up of squares that are usually 1 foot in length and 1 foot in width. And that's why we call these square feet. It's another reason. Okay? So the area is 375 square feet. All right, number 4. In an isosceles triangle, so you have to know what the word isosceles means. Isosceles means the triangle has 2 congruent sides, or 2 equal sides, and they're called legs. Okay? So I'm going to draw that right in my setup column. These guys are called the legs. Like think of it like triangles run on their legs. You have 2 legs. It says the length of one of the legs is 4 times the length of the base decreased by 8. That whole sentence needs to be translated. The length of one of the legs is 4 times the length of the base decreased by 8. What object comes at the end of the sentence? I know some people say, well, 8 comes at the end, but 8 is a number. The object that comes at the end of the sentence is the base's length. That will be x. So x will be the length of the base, so I'm just going to call it base for here. And I'm going to label it on my triangle. Now, the length of one of the legs is 4 times the length of x, or 4 times x, decreased by 8. Decreased by means to subtract, and we subtract in the order that we read for decreased by. So 4x minus 8 would be one of the legs. I have 2 legs on the triangle, so I'm going to label them both 4x minus 8, 4x minus 8. And now I have my triangle labeled and my whole problem is set up. The next sentence says, if the perimeter of the triangle is 443, we want to find the length of one of the legs. The perimeter means I'm going to add up all of the sides. And again, you have to be a good security guard. Security guard walks the perimeter. They walk around the whole object. So I must add up all the sides. So I'll start off with the 4x minus 8 plus the x. And notice I'm checking off while I do it. Plus the 4x minus 8. And that equals 443. And now I solve my equation again. So 4x plus 1x plus 4x is 9x. Negative 8 plus negative 8 is negative 16 equals 443. Add 16 to both sides. We get 9x equals 459. Divide by 9. And x is 51. I'm being asked to find the length of one of the legs. The legs are 4x minus 8. I now know what x is. It's 51. So I'll substitute 51 in for x. 4 times 51 is, let's see if I can do this in my head. 4 times 51 is 204. Minus 8 is 196. That's the length of one of the legs. There are no units in the problem. And I said if there were no units in the problem, I would not expect units in the answer. All right. Number 5. Rob, Dylan, and PJ all collect baseball cards. So I'm going to do my word problem, my 3-column setup. Dylan has triple the number of baseball cards PJ has, and Rob has twice the number of cards Dylan has. I need to read this and know when to stop. So, Dylan has triple the number of baseball cards PJ has, and a stop right there because I got to a comma and an and. This is a piece of information. Dylan has triple the number of cards PJ has. PJ is coming at the end of the sentence. The number of cards he has will be x. So x is the number of cards PJ has. Dylan has triple x. Triple x is 3 times x, or 3x. So 3x will be the number of cards Dylan has. Then I must read the next part. The next part says, and Rob has twice the number of cards Dylan has. Dylan is at the end of the sentence, but kind of in, I think, problem number 2. Dylan is 3x already. If I want twice 3x, twice 3x is 6x. So 6x is the number of cards Rob has. And now I can set up my equation because it'll say in the next sentence, their collections altogether have 1,000 baseball cards. So if I take the x, PJ's, and add on Dylan's number of cards, 3x, and then add on Rob's number of cards, 6x, that will equal 1,000. Okay? And we'll solve this equation and we'll get an x value and then we'll find out what the question's asking. So 1x plus 3x plus 6x, all like terms, that comes out to 10x. That equals 1,000 divided by 10, and x equals 100. So x is 100. Now the question is a little different this time. It says, how many cards do Rob and PJ have together? Well, I look back to my setup column. X was the number of cards PJ has, and we found X's value. So we know PJ has 100 cards. Okay? We want to find out what PJ and Rob have together. So I will go to the Rob setup, and I will see Rob has 6x cards, but X is 100. So 6 times 100, I'm just substituting in for X. 6 times 100 is 600, and that's Rob's number of cards. And now I want to get the total number of cards Rob and PJ have together. So I'll take my 600 and my 100 and add them together. 600 plus 100 equals 700. So altogether, those two boys have 700 cards. All right, number 6. Find 4 consecutive integers whose sum is 2. And I'm just going to actually do a little side note for everybody here on consecutive integers. Here's the deal, okay? Consecutive means in a row. Integers means basically numbers without decimals. So here's an example of consecutive integers. 3, 4, 5, and I'll even go up to 6. To get from here to here, 3 to 4, I add 1. To get from 3 to 5, I add 2. To get from 3 to 6, I add 3. So now the idea is that let's say I didn't know what number I was starting with. I'm going to call this number, instead of a 3, I'm going to call it x. The next one on the list would be x plus 1. The next one after that would be x plus 2. The next one after that would be x plus 3. Those are consecutive integers. And the nice thing about consecutive integers is this is always the setup. Okay? This is always the setup. So it says find 4 consecutive integers whose sum is 2. So we're going to let x equal the first consecutive integer. I'm abbreviating that with CI. First consecutive integer. The next one, I have to add 1 to x. So for example, if x was 4, 4 plus 1 is 5. That's the next one. So x plus 1 is the second consecutive integer. They want me to find 4 of them, so I have to go up to 4 of these things. The next one, instead of adding 1, I'll add 2. That's the third consecutive integer. And x plus 3 is the fourth consecutive integer. I have to find 4 of these consecutive integers. I'll stop there because I have 4 of them now, whose sum is 2. I'm going to make this column a little wider here. So I'm going to add up these 4. That's what the sum means, to add up to 2. So I'm going to write equals 2, and I'm going to add these 4 things. So I have x plus 1 plus x plus 2 plus x plus 3. Those are my 4 consecutive integers being added up. And now I combine my like terms and solve. So I have x plus x plus x plus x, which is 4x. I have 1 plus 2 plus 3, which is 6, equals 2. Subtract 6 on both sides. I get 4x equals negative 4, divided by 4, and x is negative 1. Now, the third column is reserved for the answer. That says find 4 integers. I need 4 answers. Well, my first consecutive integer is negative 1, because in my setup column, I said x was the first one. So my first one was negative 1. Now, my second one is the next one up, which is negative 1 plus 1, which is 0. My next one from there would be negative 1 plus 2, or just 1. At this point, you can count. And the next one would be 2. And there are my 4 consecutive integers whose sum is 2. And if I wanted to check this a little bit, I would take the 4 consecutive guys and add them. And notice negative 1 plus 0 is negative 1. Negative 1 plus 1 is 0. And 0 plus 2 is 2. And it works. All right, 3 more problems. Number 7 says if the sum of 3 consecutive odd integers is 123, find the largest consecutive integer. So, by the way, this probably should say odd. Find the largest consecutive odd integer. But before we do this problem, I want to do a little side note about odds and evens. Okay? Here are 3 consecutive even integers. 2. No, I'm not going to start off with 2. Sorry. I'm going to start off with 10. 10, 12, 14. And here are 3 consecutive odd integers. 23, 25, 27. But the thing that's cool about odds is that they follow the same, odds and evens, they actually follow the same pattern. If I want to go from the 10 to the 12, I just add 2. If I want to go from the 10 to the 14, I add 4. So if I started off instead of 10, instead of 10, I had an x. The next one would be x plus 2, and the next one would be x plus 4. Okay? Now, oddly enough, no pun intended, going from the 23 to the 25, I add 2. Going from the 23 to the 27, I add 4. So, if I started off with x, I would take x and still add 2, and I would take x and still add 4. So for consecutive, even, and odd, integer problems, these are both the same thing. They're the same setup. For consecutive, even, and odd integers, it's the same setup. So now we're going to go back. If the sum of 3 consecutive odd integers is 123, find the largest consecutive odd integer. So x will be my first consecutive, C, O for odd, and I for integer. Just abbreviating, because I don't want to write consecutive odd integers every single time. I want 3 of these things. The next one is not x plus 1. It's x plus 2, which is the second consecutive odd integer. The next one after that is x plus 4. That's the third consecutive odd integer. And now the sum of these 3 is 123. So I have to add them up to get 123. So I have my x plus 2 plus x plus 4. And now I need to combine my like terms. So x plus x plus x is 3x. 2 plus 4 is 6. I get 123. Subtract 6 from both sides. I get 3x is 117. Divide by 3. And x is 39. Okay? X is 39. I would like to find the largest consecutive odd integer. Now, if I think for a minute, if I had, for example, 5, 7, 9, the largest one comes at the end. It has to be the third consecutive odd integer. That's the largest one. If you're not sure of that, just plug an x into all 3 and you'll see that. So 39 is the x value, but the largest guy is the x plus 4. That's the third consecutive odd integer. So I want to evaluate this when x is 39. So 39 plus 4 is 43. That's the third consecutive odd integer. Okay. All right, 2 more. Number 8. Nope, that's not number 8. Number 8. This one's tougher. Find the largest of 3 consecutive even integers, such that the sum of the first 2 results in the third increased by 34. Setup is easy. Consecutive evens. X is the first, C for consecutive, E for even this time, I for integer. The next one is x plus 2. That's the second consecutive even integer. The third one is x plus 4. That's the third consecutive even integer. Now, this is the tough part. The sum of the first 2 results in the third increased by 34. The key with this sentence is you have to find the equal sign. The equal sign is results in. Result is an equal sign. Okay? If you get a result of 80 on your test, that means your test grade equals 80. So here's my equal sign. The sum of the first 2. Sum means to add. I want to add up the first 2 consecutive evens. So that's x plus 2 equals the third. Here's the third, x plus 4, increased by 34. If I take x plus 4, I need to increase it, which means add 34 to it to get up to what I needed to get. So that's where this comes in. The increase by 34, I'm adding 34 onto that side. So now I have an x plus 2, which is 2x plus 2, equals x plus 4 plus 34 is x plus 38. I'll subtract x from both sides. So we get x plus 2 equals 38. Subtract 2 from both sides. And x equals 36. I want to find the largest. The find actually comes here first. Find the largest of the consecutive integers, which would be the third consecutive even integer. So my x plus 4 is the third consecutive even integer. I'll take 36 and plug it in for x. So 36 plus 4 equals 40. That's my final answer. And one more, and then the video's over. Number 9. This one's tricky if I remember correctly. All right. What is the smallest of 4 consecutive integers? So right off the bat, 4 consecutive integers. I want to write that. Notice it doesn't say even and it doesn't say odd. So I go back to my original setup, if you remember, for consecutive regular old integers. In number 6, we did it. X, x plus 1, x plus 2, x plus 3. That's the setup. So here's my setup. 4 consecutive integers. X is the first consecutive integer. X plus 1 is the second consecutive integer. X plus 2 is the third consecutive integer. And x plus 4 is the fourth consecutive integer. Now here's the tough part. You have to find the equal sign when you read the sentence. 19 less than the sum of the second and the third is equal to the fourth. Here's my equal sign right here. That separates this. So actually, I want to unhighlight my highlight. Now that I underline the equal part. And I want to look before the equal sign. So I want to highlight that in yellow. 19 less than the sum of the second and the third. Less than gets translated backwards. So 19 less than means minus 19. And then I want to fill in something in front of it. The sum of the second and the third. Here are the second and the third consecutive integers, and I need to sum them. So my sum is x plus 1 plus x plus 2. This is the sum of the second and the third. Right here. And I have to subtract 19 because 19 less than was there. Is equal to the fourth, meaning the fourth consecutive integer. X plus 4. Now, some people in the past have been bothered by this problem because the first consecutive integer is never mentioned. But that's okay. We still have an equation. We can still solve it. And there's x in there, so we'll be able to get the first consecutive integer. So now I combine my like terms. I have my x and x is 2x. 1 plus 2 is 3. 3 minus 19 is negative 16 equals x plus 4. Subtract x on both sides. I get x minus 16 equals 4. Add 16 to both sides, and x is 20. The question says, what is the smallest of 4 consecutive integers? Well, that smallest would be the first one. And the first one is x. So x is the first or the smallest consecutive integer. And guess what? That's just 20. And we're done. And that's the end of the movie, folks. Hope you enjoyed it.